In his 1941 short story, Runaround, Isaac Asimov created his three laws of robotics. A robot may not injure a human being or, through inaction, allow a human being to come to harm. A robot must obey orders given it by human beings, except where such orders would conflict with the first law. And a robot must protect its own existence as long as such protection does not conflict with the first or second law. In this episode of the Plutopia podcast, Bill Smart and Cindy Grimm feel Asimov's laws miss the mark when it comes to laws of robotics.
Asimov's three laws, everyone brings them up. They were a plot device by a guy who'd never seen a robot to drive story. And if you were to think about it for 5 seconds, there are reasonable four things to come up with. If you think about it for 10 seconds, they fall apart all over the place. We do need structures, and we do need a way of thinking about the ethics and morality and social impact of robots. But I think it's way more nuanced, way more nuanced than you can compile into a paragraph of text.
I mean, something even simple like, robots should always do what you tell them to do. They should always get out of your way. That might not actually make sense. So if all the robots are all trying to get out of your way and so on, but there's a needy delivery or they actually need to get somewhere, then maybe the robot does actually need to take priority over the humans. Like, you can't really have those conversations when you start from the place of, all robots should kowtow to humans.
Hey everybody, welcome to the latest episode of the Plutopia News Network podcast. I'm John Lebkowski. I'm here with my co-host and partner in crime, Scoop Sweeney, and our contributor, the great Wendy Grossman. Our guests today are Bill Smart and Cindy Grimm. Cindy is an American computer scientist, roboticist, and mechanical engineer. Bill researches the areas of robotics and machine learning. They're both professors at the College of Engineering at Oregon State University. And I think we're going to talk a bit about robots. So welcome.
Yeah, pleasure.
Thank you.
Yeah, glad to have you here.
So Bill and Cindy and I all met at an annual conference called We Robot, which was founded by Michael Frumkin, Ian Kerr, and Ryan Kalo. And the thing that really interested me about a lot of your work is that you explain things in ways that no one else does. And I particularly liked a couple of years ago when you explained why everything we think we know about sensors and what robots are seeing and quote hearing and so on were completely wrong. And I think the phrase you used was late, noisy, and wrong. And I learned more from that than almost anything, because I write this stuff and I kind of hand wave all the physics bits. So maybe that would be a good place to start if you feel like it, explaining why what people think robots and software are doing is just not what it is actually doing.
So I extended Bill's original definition to sensors are noisy, wrong, and late, and usually don't measure what you actually want to measure.
Yes, that's right. I forgot the fourth bit.
Yeah. And I think Bill's favorite example of this is a typical laser rangefinder. The idea is light comes out, bounces off of something, comes back. If you measure how long it took to go out and bounce and come back, then that gives you some idea of how far away something is, like in a specific direction. So the doesn't really measure what you want. Is really the question you want to ask is there something in front of me? Am I about to run into something? Is something about to run into me? And instead what you get is a noisy measurement that says in that particular direction is something maybe 2.5 meters, but I could be right, I could be wrong. It should be close to 2.5, might not quite be that. And if you actually look at the mechanics of what's happening, you're actually just counting clock ticks until that light gets reflected. And so if that light happens to go through a window, it doesn't come back. If you happen to hit something like black velvet, it doesn't come back. If you happen to bounce around or if there's some other light shining to you, then you get the wrong number out. So when we say sensors, they're really these very noisy types of things that are measuring something physical in the world that is hopefully closely related to what you actually want, but usually isn't.
Yeah, I think for me, like when we're talking to people who are not technical, I think they're like you, Wendy. Like they have this sort of vague idea that sensors measure stuff, but they're not really sure what they actually measure. But they know what they want. They want distance, or they want, there's a person there, or they want this sort of higher level thing. And I think it's really helpful to understand a little bit of what's going on under the hood, like Sandeep was saying, so that you know that there's a whole bunch of assumptions from what you can measure to what you want to actually know. And the trick, I think, for us as technologists is not resorting to physics and equations and stuff that people have a hard time wrapping their heads around. And so, I think that's why I enjoyed that conference in particular, because it forces you to try to think of things in ways that people without technical background could get access to. And what's the most important thing to know about this particular sensor or this particular piece of technology? And it's very rarely like the actual details of how it works. It's more of the I don't know what the right word is. It's more of
the experiential failure. So one of the things, we did a recent study actually, and so people don't know how sensors work, but almost everybody has. So for example, we're talking on Zoom and you can turn on the automated background, and we were just talking about how, like, if you have white hair, suddenly you disappear, you come in, you come out. So when you hear the computer saw a person in an image, picture what Zoom does, right? So did it see the person or not? And you know how it gets really noisy, right? Sometimes the person's there, sometimes it's not. If there's two people, it doesn't actually do the right thing. Sometimes it chops off half your face. Sometimes it shows a floating coffee cup. So I think you can really help non-technical people understand that high-tech robotic stuff behaves pretty much like your Zoom filter. And I think like helping people understand why that happens. I think people are actually pretty good at describing the effects of these sensor failures, but they think that they work somehow differently, or they're sort of more advanced than they actually are, because suddenly they're robot sensors. But it's like, no, just like picture the tech you work with every day. That's pretty much what our robot sensors are, and that's pretty much how well they work.
There have been some incidents here in Austin and in my old neighborhood in San Francisco with bad sensing. The robo taxis and the smart cars that are supposedly smart. And you've looked at some of these failures. What's the real weakness in this attempt to have the automated self-driving cars?
Well, I think like the sensing's part of it, but when we think about you're in your car and you look forward and you see something in front of you, it's not just that you're sensing light bouncing off a car in front of you. Like you have a whole bunch of knowledge about the world and how it works. Maybe it's raining, and so your expectations are different. And I think it's not so much the raw sensing, but it's the context around that that's really hard to get into the system. When it's raining, you expect reflections from the road, and that's a subtle thing, and it's sort of hard to enumerate all the things we know about the world in a way that you can write them in software and put them into one of these self-driving cars.
I remember you talking about how digital cameras work, and that you don't really know which pixels it think the system identifies as important, and you change a few and it thinks that the same picture is not Abraham Lincoln anymore but a zebrafish. And I thought, I was thinking of wasn't it Tesla that had trouble distinguishing telling the difference between a cloud and the side of a truck?
Right.
And that seemed really relevant to understand. That seemed really relevant for me to understand how such a crash could happen.
Yeah, I think that we're using these deep neural network models now a lot, and they're super powerful and they're really good when they're good. But I think with that power, there comes our inability to predict how it's going to react in a certain situation. And so that confusing the side of a truck for a cloud is actually really reasonable given the technology, but it seems really unreasonable because when we say the car sees something, there's all this implication that it sees in the way that we do. It makes mistakes in the way that we do. But I think there's a two-edged sword here. Is that the self-driving thing's really enabled by these new technologies, but for them to work as well as they do, they kind of have to be intractable to humans. And so I think there's a real balance there.
Yeah, and I think like just the way they do it is very different than the way people do it. So I always say like it's numbers all the way down. So when you think of a picture of a person, for you, there's all this context you can bring to it. You know how big people are, you know how they move in space, you know how far away somebody is, you know how fast somebody can move, you know that it's a person wearing jeans and boots, right? So there's a whole bunch of physicality to that particular experience. You're not just seeing a person, you're like hallucinating all of your experience with what people are and what they can do. A computer basically gets an array of numbers, like a giant spreadsheet, and it's basically saying these numbers are very similar to the numbers that I saw before that were a person, so I'm just going to draw a box in the image and say that's a person. And those two are so different, but when we use language like the computer saw a person, suddenly you're thinking that it can do all of the things that you do when you see a person, right? And so I think that there's where a lot of that breakdown happens, is that the word see for you carries all of this other physical real world baggage. And for a computer, it's just, I detect a person and draw a box around it. And so I think if we just use language that said, yeah, the computer detected a bunch of pixels that were similar to people-shaped pixels last time, you really wouldn't be expecting it to always be able to find a person in the image.
Yeah,
I think
So you mentioned neural networks a minute ago, and I know that neural networks are very significant in this kind of work. Can you define neural network? Can you kind of explain what it is?
Yeah, I mean,
Can you do your spreadsheet analysis?
Yeah, there's obviously the very technical definition, but it's really a set of clever techniques for turning one set of numbers into another set of numbers. So I give you some training data, which is maybe a whole bunch of images, and then and with each image, there's a label dog and a label cat. And neural networks are just the newest technology we've got, historically the best technology we've got for learning a way to take the pixel values in the image of all the cats and be able to say that's cat, and the pixel values in the images of dogs and saying that's a dog. It's basically
a giant if then. So
yeah.
if the pixels are more brown than red, then it's a dog. If it's, I'm making this up, but so you're basically saying if I have sufficient number of pixels that are red, then there's an apple in the image, is what it comes down to. But there's just a lot of if statements in there.
I think you can think of it as a black box technology that takes images in on one side and then spits out a label for those images on the other side. And the thing that makes the technology work is some clever algorithms that let you set a whole bunch of settings within that black box to do the right thing. And the power of it comes from having a huge number of knobs. Some of the new models have millions of knobs, basically millions of values you can set to get this thing right. But because there are millions of knobs, it's really intractable for humans to look at that. So the power comes from this adaptability and this ability to learn patterns, but that is at such a low level, you can't look at one of these things and sort of really understand what it, at a fine grain, what it's doing.
And if you put in numbers that it hasn't seen before, it just makes something up.
Yeah, well, I'd argue that it doesn't make something up, but if
you
give
have
it
no idea what, like if I put in 3, like, and you've only ever put in 2 and 6 before, you don't really know what putting in 3 is going to do. And so that's where you have a new image that is not like any of the images that you've seen before. What it's going to do is it's very well mathematically defined, but it's not necessarily what you want it to do.
And so as a concrete example, suppose you were trying to differentiate pictures of dogs from pictures of cats. And you took all your pictures of dogs with one camera and all your pictures of cats with another camera. And the cat camera had a dead pixel in the middle of it. Possibly what would happen is you would learn to classify any image with a dead pixel in it as a picture of a cat. Right. And so it doesn't have this knowledge of what a cat is and what a dog is. It just sees numbers and tries to pull out correlations in those numbers.
Well, that's that
Um,
old story, isn't it? The one about the Pentagon and the test
yeah,
looking for
the
tanks.
tanks in the wood.
And
Yeah,
it
yeah.
turned
So
the system seemed to be really, really good at looking for finding tanks and identifying which picture had tanks in it. And it turned out that all the pictures of tanks had been taken on sunny days or something, and all the
yeah,
pictures without tanks had been taken on a cloudy day. So what the system had actually learned to do was tell whether the sun was shining.
yeah. I
Yeah.
mean, I don't know if the story is true or apocryphal,
I
but
know, but
that's
it's a
certainly
great story,
it's a
isn't
great
it?
story. Sure.
Well, there's a more recent version of that where they were trying to classify facial features, and they had two data sets, one that came from crime scene mugshots, and then one that came from LinkedIn photos. And it turns out they basically discovered that in LinkedIn photos you smile, and in mugshots you don't, right? And so everything else they were trying to train for was just completely washed out by that particular fact.
So
So
Jenna Ellis's mugshot from when they did the arraignment, that actually would have classified as a LinkedIn
Yeah,
picture because she did weirdly, she
you
did
smile.
smile.
There you go.
that was a weird looking mugshot.
They all were. I didn't expect them to be in color. I was very disappointed. I wanted the little number plate and the, you know.
But I think like the central part of this is that the problems we're tackling now, especially on self-driving cars, are really hard. We need these technologies that are really powerful and can really pull out these correlations and these patterns. But to have, you can't get that power without getting this intractability. And people are looking at how you can explain the decisions these things make or predict them a little bit, but it's an uphill battle. I think it's a really, really, really hard problem.
Do you consider delivery drones a robot or just a piece of machinery following programming? Because a lot of these businesses that are trying to do drone deliveries are making it sound like it's just this intelligent little robot. It's going to find you no matter what. Is that real or is that just myth?
I would call it a robot because it has to. You ask 10 roboticists what the definition of a robot is, and you'll get 15 answers. But broadly speaking, if they are sensing the world, then they are doing some computation and then taking an action based on that computation. You can call it a robot. It doesn't have to be a bright robot. It's just that's part of being a robot. And so these drones are obviously taking in information and they're using that to control what trajectory they're going on. So they don't run into anything, they don't run into the buildings, they have to figure out where they are in space. So yeah, there's a lot of computation going on. So I would call them robots. Whether they're as smart as these companies say, that's a different question. But
yeah, I would definitely call them robots. I've got a big definition of robots. So, one of the early discussions was, is the thermostat in your house a robot? Because it senses temperature, it does often a mechanical computation, and then it turns on the furnace. And so I would call that a robot. But again, like the question sort of highlights how much we anthropomorphize stuff. Because you said, is it a robot? As if a robot's kind of something special and intelligent and science fictiony. It's a mechanism with some compute in it. And if you describe it in that terms, that doesn't seem as intelligent, right? It doesn't seem as fancy. And I think that's, to Cindy's point, the language we use really frames it. Sure, drones are robots, but robots are really just sensors, computers, and motors. Like there's no intelligence there. And
Fancy hammers. You used to call them fancy hammers.
Fancy hammers, yeah.
yes.
Yeah. Just another tool, right? And they do things which look like they have agency. They make decisions based on software that looks like agentic behavior, that looks like they've got their own agenda. But really they're not, they're just following code.
Actually, one thing that I had expected to be more significant by now that sort of hasn't been is a discussion that you led for, I don't know, 5-6 years ago at least, about sort of boundaries, that no matter how fuzzy you make the boundary between, say, speeding and not speeding for a car, or turning on the furnace and not turning on the furnace, there is always a hard stop in there in the middle somewhere where the computer says this side, where it's binary, and there isn't a kind of smooth transition at all. And I always thought that we would start to see machines that seemed to us to be sentient because they reacted to boundary conditions that we can't detect. Like so that they would seem to have agency because they'd be making decisions that didn't make sense to us. Yeah, you know, like if we can't, at least I can't distinguish a tenth of a degree, you know.
Right. But I think we come preloaded as humans wanting to ascribe agency to things that look agentic, right? So your thermostat could just turn the temperature on at some point randomly, and you would try to find a reason for it, right? And you would come up with, we see faces in clouds, right? We really want to anthropomorphize stuff, and I think no matter what the decision behind it actually was, what the code was, we're going to come up with some agentic explanation for it.
Yeah, it's like people naming their Roombas and taking them on vacation with them.
Yeah, and I think that's just that's part of being human, right? Our brains have evolved to be social. We're a social species, and I think that comes with that's just what we are.
What are you learning about grasping?
Oh, me? Robots.
Yeah, that seems really fascinating.
Yeah, no, robots suck at picking anything up. So whenever I hear people talking about the robots taking over the world, I'm like, yeah, fine, they can win at Go, but they can't actually pick up the Go stones. So grasping is particularly challenging because you have to reason about an awful lot of physics. And most of the reasoning that we do about physics when we pick something up, I mean, we've had years and years and years of experience with picking physical things up, and getting that kind of data for a robot is really hard. So I have a couple projects around grasping. One of them is picking apples, and I can go out into a field and watch farmers. Basically, they scan the canopy and they are picking one apple every 3 seconds. And that's how fast they are. And they're picking them. They're carefully removing them by touch usually, so that they keep the stem intact and then peel them off. Turns out to be a hard physics problem. They have to estimate where the stem is, even if they can't actually see it, figure out how to peel it off. And then they have to carefully transport it to something that can carefully transport it without bruising it. They can't drop it. They can't knock the apple next to it off. They can't shake the whole branch. They're doing this at like 3 apples or 1 apple every 3 seconds. And we're lucky if we can actually get the gripper to the apple and actually grab it and pull it off without knocking everything down. So when I think about the gap between, when I think about the autonomous car gap, if you think about grasping and the fact that we can't even get something to physically pick something up, because that reasoning about physical objects requires knowing surface properties, estimating weight, estimating size and shape. How sticky are your fingers? How heavy is that thing? Like, that sort of reasoning is actually spectacularly difficult for a robot, partly because of sensing, but also just because there is so much that you need to know to make physics work. So by and large, robots suck at picking things up.
Yeah, I think that's a really good example of why a lot of parts of robotics are hard. So you can pick apples without having ever picked an apple before. You can probably do a pretty good job of it picking apples, because you've got a lot of intuition about picking things. Maybe you've picked oranges before. But it's really hard for us to have introspection on what we're doing on a lot of these things. And so to get a robot to do it, you've got to write some software, and to write the software, you've got to understand the steps, and to understand the steps, you have to have introspection about how you do it. And so, when you pick up a pen, like, how do you do that? You can't really tell me how you do that at the level that I would need to write some software on a robot. I think that's true for a whole bunch of stuff: physical manipulation, driving a car, right? When you're driving a car, tell me exactly what you're doing and what you're looking for every time you move your eyes. It's just really hard.
I've always thought it was really weird that this assumption that a robot should be anthropomorphic. I mean, it makes sense to me that you would have specialized robots who would be built for what it is specifically they're doing, but everybody seems to want to have a robot that looks and moves like a human. It seems kind of impractical to me.
So my 15-year, 20-year projection is that we will do exactly that. We will have a bunch of special purpose robots, each that does a specific task. There's no real reason to have an anthropomorphic human. So, I mean, I think about the difference between this, my cell phone, and the computer that I'm staring at. So when you look at your cell phone, what has it got? It's got a whole bunch of little tiny apps, each of which that does something specific, right? Unlike your computer, which is sort of this notion of this big computing box. And I think what you'll see over time is you'll have the robot that mows your lawn. You'll have the special purpose dishes with the dishwasher where the handles some of the washing for you. But you are certainly not going to have an anthropomorphic robot that comes in and does your laundry and then does your dishes and then makes you dinner. You're going to have the coffee maker, the toaster, the dishwasher, and the laundry machine that maybe will actually fold your clothes for you. So I think people want the Rosie the robot, but from a practical engineering standpoint, it just doesn't make any sense.
Well, that's one of those things, isn't it? People want a servant.
That's a whole nother topic. Look at robots and what we think about them. But I also think it just comes down to, so I have this running, my favorite example of this is like, if you've ever been in an airport or a high-end hotel or whatnot, you've got these machines that you put the coffee cup down and you push the button and grinding happens and you get a cappuccino out, right? Then you can go to San Francisco Airport and they have a $35,000 arm that will do the whole, go pick up the coffee cup, put it down, go pick up this and do that. And I'm like, we have a robot coffee maker already. It's called a coffee. Like, why are we using an anthropomorphic arm to make a cup of espresso when you can just buy one of these $2,000 machines that makes perfectly fine cups of espresso?
I think the argument that people use is that if you're going to have robots in the short term, in the next 20 years, in our lives, in our homes and in our factories, those homes and factories are built for human-shaped objects. And so you've got to be at least what you call plug compatible with a human. You've got to have roughly the same shape. You've got to be able to handle stairs and that's whether or not you believe that argument, that's an argument you could make. But I think we're really influenced by media. You said Rosie the robot, the Asimov robots, C-3PO. A lot of people who are working in robotics and now were influenced by Star Wars. And you can see some of that influence. If you look at the types of robots built in different parts of the world, it reflects the popular media heritage of that part of the world. Right, there are a lot of Gundams in Japan, and there are a lot of Rosie the robots in the US. And I think you can't really, you can't discount that. I think, and when you Google for robot, then you just get pictures of these humanoid things holding vacuum cleaners. Like a vacuum cleaning robot is a robot holding a vacuum cleaner, because that's the mental model that I think a lot of people still have.
You talk about the media being an influence. The media is currently overwhelmed by artificial intelligence. Everything is AI this and AI that. And it's
Sure.
How much will AI influence the design and implementation of robots? I mean, is that something you need, or do you not need?
So what do you mean? How will it influence how we make robots, or how will it be a part of robots going
Right.
So I think robots have always had artificial intelligence. AI is a field that's been going for 60 years. And I used to characterize AI as the computer science we don't know how to do yet. The new models are really powerful and really seductive. The large language models, especially, they're just another tool. They'll be in robots, I'm sure, and they'll be doing things in robots, but it's just more software. I think the hype around it in some ways justified, because these models are more powerful than anything I've ever seen before, and I'm really optimistic about them. But at the same time, they're just software. It's just another new technique that we're using, and there's no magic to them. They're super powerful, but they're not intelligent. in any meaningful way. They will enable a whole bunch of stuff on robots. So being able to say things in a language, English or Japanese or German, and then translating that to stuff the robot can understand and act on. We can do that much more efficiently, much more effectively now than we were able to even a year ago. So they're going to really radically improve that. They're going to, you can use them to figure out context in the world, which we talked about a little bit before, which I think is going to improve things. But it's still just, it's code.
It's
right?
just software.
It's
Software
not
and data.
But don't they want to eliminate humans and take over the world?
Oh, just stop.
Please don't.
Sorry.
Yeah, no, I know. There's a great old science fiction story that gets to this to some extent. I think it's from 1940s, and so the basic scenario is this newspaper gets in an anthropomorphic robot, so it's a humanoid robot, and it starts off by doing copy editing. So it's like typing things up for people, and then it like starts writing things for people. And it basically is the story describes what is now Microsoft Word. And what I find really interesting about that particular story is that they completely envisioned Microsoft Word and ChatGPT doing like your text editing for you and writing copy for you and whatnot. But because of the limitations of the technology at the time, they envisioned a humanoid robot sitting at a typewriter doing this. And so I feel like there will be changes with AI, but you know, in the end, people are still doing the same tasks that they were doing, and you know, the AI will kick in and help with some parts of that, but the chance of it doing the whole end-to-end task and doing it in the way that you think it is just not going to happen. So it's useful, it's powerful, but you know, in the end, it's basically just a word predictor. It's like, what's the best word to put after the end of the sentence? And so what can you do with that? You can do text summaries, you can do maybe take a couple ideas and flesh them out into nice prose, but you know, sort of what fundamentally can you do with that you can't do right now? Not really sure.
So if we don't have to worry about robots deciding to take over the world or AIs deciding to take over the world, what should we worry about? What are the things we should kind of look out for as we move forward with both robotics and AI?
Bias, discrimination, and killing the golden goose. So the last one, so the bias and discrimination, right? So if you train these models on existing data, they will inherit all the biases that are in the existing data. It's also really, so that's one big problem. The killing the golden goose is sort of an interesting argument that's a little bit more complicated, which is that we've just trained ChatGPT on the entire internet, right? So all screenplays that are out there, writing that are out there, right? So you could take a ChatGPT, you could train it on all of the paintings that Dolly made. That's great. You've like sucked up all of this creative energy. But if you then set up economic incentives, so you just have ChatGPT generating more stuff, you sort of cut off the pipeline of more people generating more content for the internet, right? Like the AI is just going to generate versions of what is already out there. It's not really going to do anything substantially new, right? It's just going to sort of regurgitate things that it's seen with slight variations. So if you are not careful and you remove the economic incentives for the next Taylor Swift to be writing songs, all you'll ever get is copies of Taylor Swift, which could be good, could be bad, depending on your point of view. But so I think the thing to watch out for is more, so the bias, and then also like, do you really want more of the same? How do you keep incentivizing people making new creative content? How do you help with the pipeline? Like, you know, people don't suddenly become Taylor Swift or famous writers, right? So how do you keep the ecosystem going so that people keep generating new content for the things that these models are being trained on?
Yeah, for me, the things I think about a lot are the tools that we have now, the AI tools we have now, let you do things easily that you used to have to be an expert to do. So faking photographs and video, coming up with audio that never existed. We can now produce false information on a scale. I, as an individual, can produce false information on a scale that's never been seen before. And so I worry about, I don't want to be over dramatic and say the death of truth, but there's going to be less truth to false information out there about a whole bunch of stuff. I can produce, with these new AI tools, I can train them on the New York Times articles, and I can produce an article in the style of the New York Times that says anything I like. And then I circulate it. People don't have a good filter for this stuff sometimes. So I worry about that. I worry about the democratizing of false information. For the robot thing, I think, I worry a little bit about how it impacts the economy and jobs. I think, a lot of studies say that on net, we will gain jobs with robots taking over some job functions, but, someone's always going to lose a job. And, if you've been in a position for 30 years and a robot comes along and they automate that, then, if you're 50, if you're 60, it's hard to get reskilled, and it's hard to get a new gig in some of the parts of the economy. So I worry about that a little bit. I don't think it's going to catastrophically crash our economy, but there are going to be people who are out of a job.
Yeah, it sounds like something that happened to the music industry back when producers began sampling other people's music and creating what they thought was new music. They weren't creating anything new. They were just mixing and doing mashups. And that's what it seemed like, ChatGPT is doing. It's not making anything new. It's just doing a mashup. It's a new way of sampling.
Yeah, but let's have an interesting take on it, because people do sample and they loop and they recombine old stuff, but often on top of that, there's a new element. Like there's an artist who comes in and does that new element. And I think to Cindy's point, figuring out a way to do that with these other media, where there's novelty coming in, there's incentives for people to produce new creative works, and maybe they're using these tools as part of that, or as a background for that, or as a really catchy hook for their new song. But figuring out how to get that balance so you're not just strictly recycling and resampling.
I mean, I think physical robots only bother me in this sense. So we have these little starship robots that run around campus here and deliver food. And in essence, they are using all of our public sidewalk infrastructure in order to do food delivery. And so there are cases where there'll be a lineup of 5 of these and somebody in a wheelchair or bicycle can't get past them, right? So I think there is, some risk, just like if you think way back when, we used to think that people were allowed on streets, and that people could walk in streets and play in streets and use them as a space. And then cars came along and they drove fast enough that they were killing people left, right, and center. And so the net effect was like, oh, well, we just won't let people, they invented jaywalking, right? We won't let people on the streets anymore. And so I worry a little bit that there's a lot of shared public spaces that if you start filling them up with, delivery robots and delivery drones and so on, that you'll be losing that public space for everybody else, right? So I think like robots do have this sort of physical presence and they need to be in your spaces. And we are right now not very protective of our public spaces. And so that's, I think, something else that's sort of under the radar right now. But as you start filling up streets and sidewalks with automated devices, at what point do you no longer have space for people to move around?
I think too, like the sort of the high level bit that I worry about, and this is not specific to AI or robotics, it's just technology in general, is as these new technologies come in, you're going to have to pay for them, obviously. And I think thinking really hard about how that changes power inequities. And so does it basically pull people further apart to the people who can afford to use and deploy this technology and the people who can't? And what does that do societally, right? So, if you think about sidewalk robots, if a bunch of people can pay for the delivery and pay for the robots and the sidewalks get crowded out, then does that mean that people with humans with sidewalk delivery jobs get crowded out and that job goes away? So think about the larger societal power imbalances, and can we use robots and AI and just technology in general, being careful to think about how we can use that to close that differential rather than accentuate it.
Well, there's a
It
bunch of
sounds like maybe we need something like Asimov's law of robotics, only it would be really different.
No. Sorry.
Well, so I agree we need something like it, but I agree it would be so different as to be unrecognizable as Asimov. Asimov's three laws, everyone brings them up. They were a plot device by a guy who'd never seen a robot to drive story. And if you were to think about it for 5 seconds, there are reasonable four things to come up with. If you think about it for 10 seconds, they fall apart all over the place. We do need structures, and we do need a way of thinking about the ethics and morality and social impact of robots. But I think it's way more nuanced, way more nuanced than you can compile into a paragraph of text.
I mean, something even simple like, robots should always do what you tell them to do. They should always get out of your way. That might not actually make sense. So if all the robots are all trying to get out of your way and so on, but there's a needy delivery or they actually need to get somewhere, then maybe the robot does actually need to take priority over the humans. Like, you can't really have those conversations when you start from the place of, all robots should kowtow to humans.
Did you see the XKCD cartoon about the Asimov laws, in which they show what happens if you change the order of the laws?
Yeah.
We'll have to link to it. We'll have to link to it from the blog. But basically, if you put them in the wrong order, the Earth blows up, and there are an awful lot of wrong orders.
Sure, but to tie it back to Wendy's intro, we met at the We Robot conference, and that is a great conference because it has policy scholars, legal scholars, practitioners, and technologists all in one space. And I think when you talk about how we should think about robots and the ethics and the morality around robots and all that, you get very facile discussions. Very, Asimov comes up, the trolley problem comes up, the paperclip problem comes up. And those are fine problems if you're a philosopher or if you're in a corner of the discipline. But they're not nuanced enough to take into account what technology actually is. And I think we need to come up with these, the replacements for these oversimplified thought experiments. We need to have people at conferences like We Robot, where you actually have card-carrying roboticists talk to card-carrying legal scholars and figure out the nuances and the subtleties of it, because all of the cartoon solutions that people come up with, they're great talking points, and there are whole conferences about the trolley problem. But I would go out on a limb and say the trolley problem's nonsense because it never comes up. And I think that we need more people from different disciplines to talk together and figure out the details of this. We're starting to see that in the field, and I think We Robot's a great venue for that. I'd encourage you.
Actually, a couple of years ago, we actually had a philosopher, give a paper about the trolley problem and why it was, it was just a thought experiment that shouldn't be used in any practical way.
Yeah.
I mean, to echo that, I come back to channeling Kate Darling. It's the widget, stupid. So pretty much anything you're going to develop with AI or robotics or technology, it has a task, right? It's going to go do something. It's going to deliver food. It's going to cook food. It's going to be a companion. And so every single one of those already has, if you narrow it down to what is that robot or AI going to do and how is it going to affect the people it talks to, suddenly you actually have something concrete to do a risk-benefit analysis. Trying to talk about robotics and AI in the abstract is you just end up in these sort of, I don't know, what was the right term for these? There's just sort of these facile conversations that don't really mean anything, right? So really where the rubber meets the road is we have 50 Starship robots rolling around campus. Do we, at times they will end up with 5 in a row. Do we want to go talk to the Starship Robot company and basically say, you need to come up with more delivery routes so that you never have a place where 5 robots are in a row, because then people can't get across the street, right? So when you start actually talking actual physical delivery robots on a physical campus with actual streets and sidewalks, and they get stuck on the train tracks, you can start to ask things like, is it worth, can we add 2 minutes to everybody's food delivery so that we guarantee that there's never any place where somebody in a wheelchair can't get around the robot, right? So we could do that, but without having something actually like an actual concrete task, you can't talk about ethics, you can't talk about risk benefit, you can't talk about who's going to lose their job and so on. So I guess just in general conversations about robots and AI, you really need to say, well, what task is it doing and how is it being implemented and who's going to be affected for that task? Then you can actually get to some reasonable discussion. That's very long-winded.
Does martial arts have any influence over the robotics work you guys are doing?
It gives me a place to clear my head so I can do the robotics work that I do. I don't know if there's a general, I don't know if there's a.
I mean, I think it does. There's actually a couple high school students who came and interviewed us at the martial arts gym and talked about robotics as well. And so that was kind of cute. We came up with some links. I mean, I think both martial artists and, sort of robotics, it seems really simple on the outside, and we have all these movies that show like these magic martial arts things, but if you actually go take a martial arts class, it looks nothing like what's on the movies. So I think they do share that in common, that there's sort of this abstract visualization of what martial arts is, but when you actually get down to it, it's trying to do a choke this way and your wrist is in the wrong position, right? So there is that sort of notion of movie land and the real world. And no single answer. Like there's no single, the whole Karate Kid thing, the move that will end all moves, is just bogus.
That actually reminds me that you used to say that anytime somebody shows you a video clip of a robot doing something, always ask how much it's been speeded up. Is that getting less true, do you think?
No.
We actually just showed a video this last Friday that was 60 times sped up. No, it's one, not only is it probably sped up, but 2, it was probably the only time the robot actually did that successfully.
Well, but we were at Boston Dynamics this year and we saw them doing backflips, and they were actually doing backflips in front of us, and they weren't, there wasn't any trickery involved that I could see.
Yeah. I mean, it's not universally true, but when you see videos of robots on the web, it's kind of, I'll tie it back to martial arts, it's kind of like seeing, martial arts videos, in that you get to choose the one time that it worked, and you get to choose the best angle, and you get to choose the framing for it.
It's sort of like psychics presenting the results of their tests.
Right.
Yeah.
Right. And I'm not saying that people are being disingenuous, but I think, there is, I really like Cindy's analogy of there's this, what robots are, but really it's just code, and like what martial arts fights look like. It's not Bruce Lee, it's learning that you should put your thumb here instead of your thumb here when you're doing the thing, because it gives you more structure, blah, 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 blah. So everything is detail work that leads to this big thing, and it's getting the details right. That's the important bit.
Yeah, I guess it's the difference. Like if you go watch the Dancing Atlas video, right? And he does all these awesome moves that are they look really cool in the video. They got the music that goes with it. But then when he was actually there, it's like the guy pushed a button and it did the little pre-recorded dance. And then he pushed the button and it went to the box and fell off the box on the backflip, right? So, like you begin to realize that whole movie production, it looks really cool, but like every single one of those pieces was carefully scripted and then strung together. And they had the one take where the robot did not fall off the box, right?
Yeah.
So,
and I think with that, it's, again, it's not people being disingenuous, but maybe it looks easy when you see the final edited video, and when you see it live, you realize it's really hard. It's really, really hard.
Well, there's another side of that, which is that a lot of the AI, what passes for AI today, is stuff that humans is only possible because thousands of humans have sat there and labeled photographs and labeled bits of text and picked out keywords. And one of the fascinating things for me was a book by Marielle Gray and Siddharth Suri called, I think, Ghost Work. And they talked about people whose job it is to do things like when you call an Uber and it arrives, there's a human back in the loop somewhere who makes sure that the identity check is correct. And there are a lot of these hidden humans in these supposed AI services. And they're not stressed because venture capitalists don't like to hear about lots of humans in the loop. Though what they want to hear is that this is jazzy new technology. And part of the company's marketing is we are AI, we are really clever, and nobody wants to call attention to the sort of thousands of ghost workers as they call them. And that actually making these people invisible has really struck me as a here and now present harm. And so I get really frustrated when they start talking about it's going to take all our jobs, and what it's in fact doing is creating all these jobs, but basically pretending the humans don't exist to fill them.
I mean, that kind of goes back to my golden goose thing, I think, is that like every single one of these, like you need training data, right? And we just happen to have Flickr. That's kind of handy. You have a bunch of labeled images. We had the concentration game, which labeled more images. I think maybe if people understood a little more of how the data, like how much data has to get created and labeled by human labels, they would understand that like there's if you want your AI to do this instead of this, you have to go in there and create all of that labeled training data. And that's somebody's got to do that, right? Somebody's got to figure out how to write the chat queries properly. So yeah, there is a whole I think ChatGPT would seem less magical if people understood that it's hours and hours and hours of people labeling and cleaning up data.
I always thought they'd understand it better if they didn't think of it as if they stopped thinking of it as words in text. I think the words, having it as words in text, really makes it deceptively seem intelligent. Whereas nobody has any question when they look at the image generators that it's generating something in response to a prompt, and that if you change the prompt you get a different response. And I think there's something particular about the language models that confuses people.
I think like there's some studies that basically, I mean, when you see something written in text, it's got more weight and reality than something not written in text, right? Something you've just heard. And so I think that plays into it too, right? So you're also going to filter, right? So you type something, and if it does something stupid, if it's really funny, you'll post it. But if it's just kind of stupid, then you'll just keep going. So you're really only ever going to post the really cool, interesting things it did, and the really crazy, stupid things it did. The 3 hours of you typing there, these sort of prompts and it making garbage, you're not going to post because it's not interesting. I mean, I played around with Dolly just recently for a talk, and I was putting in prompts and trying to get out images that I could put in the presentation, and I was just floored at how many of those were totally useless. So I managed to pull out a couple of them that were kind of okay for the talk, but I mean, a lot of those were just kind of garbage.
I may have read too many science fiction novels, but one of my nightmare scenarios that comes up when I think about AI and robots is the killer military robot that's out there, the autonomous killer military robot. Do you ever think of that? Does it bother you? And is there any way that could ever be prevented? Because someone's out there talking about it and thinking about it.
Yeah. So the US already has autonomous weapons. There are point defense systems on some of our naval ships where basically they will shoot down anything flying towards the ship autonomously without a human in the loop. And those are fine, I think, because they only shoot down things traveling fast enough, low enough, straight enough, such, a set of conditions such that can be a missile. I think from all the folks in the military that I've talked to, we're never going to have fully autonomous weapons. Because of the way the military is structured, there always has to be a human in that loop somewhere who has command authority over the weapon, because they want a human to ultimately bear responsibility for that, and that is very deeply ingrained in the culture. I think they want weapons that reduce the risk of harm to humans, and so that's maybe pushing autonomy into them. But I would be very surprised if we ever deploy a weapon that's not in a very limited context, like a naval vessel underway in the middle of the ocean, where everything you see is going to be a bad guy. I would be very surprised if we deploy a system that is autonomous and the military buys off on it. So it doesn't worry me. I think that doesn't worry me. It doesn't worry me for the US or for many nation states. Now, when you have non-state actors, that's potentially troubling, right? But then there are also other things that other devices, other technologies they can use that are equally as troubling, I think. I think too, when you think about autonomous weapons, you often think about them in this very targeted way. They're applying force in a very targeted way. Is that better or worse than carpet bombing? Right? Our cruise missiles, which are relatively precision strike weapons, is that better or worse than carpet bombing to achieve the same military objective? And I think for the US, for the UK, for many nations with a stable government oversight of the military, I'm not overly concerned. I'm less concerned about that than cluster munitions, for example, or landmines. For non-state actors, that there's a risk there, but there's a risk with many technologies too.
Yeah. But see previous comment about making things easy that were not easy before, right? So delivering, drones are getting to the point where they could autonomously fly from point A to point B. You pick anybody who is now interested in getting a drone to fly from point A to point B with a grenade on top, right? And that suddenly becomes a lot easier if you don't have to be line of sight with the drone, right? You just program it where to go. So same basic problem of make some things easy that you wish wouldn't be easy. I think if you're, and also again, it's a task, right? So if you think about the military and their task objectives are to minimize civilian harm, usually while achieving their military target. And autonomous killer robots just don't figure in there in anything useful. I think I would be more worried about surveillance. If you're going to be worried about state actors or sort of big state government, I would be far more worried about police cars being equipped with license plate detectors that are tracking every single license plate in town than I would be about a military robot going. Well, not to mention the military robots would run out of ammunition eventually, right? So they're not very self-repairing. They require a ton of maintenance. They require, they would just break.
I think it will change the nature of military engagements. And so there are probably second-order effects from that. So if you look at Ukraine, drones are being used extensively in Ukraine, and that changes the value of a main battle tank. Because, a drone, to Cindy's point, a drone with a single explosive charge can, with very little risk to a human, engage with these large, traditional military assets. And I think that's going to change how we think about combat, how we think about how we use humans in combat. I think it does have a repercussion on the threshold to actually get into a shooting war. If you don't have to endanger your humans, and you can do it with drones and with semi-autonomous robots, I think that changes the political decision about combat. So maybe I do worry a little bit about that. It maybe lowers the threshold, whereas you might not be willing to send young men and women into combat. You might be willing to send robots in.
I would love to think that was true, but the wars we're seeing at the moment are being waged by people who don't care at all about hurting civilians.
Right.
Yeah.
I don't know. Maybe the I don't know, maybe the cynical part of me says that has a re-election repercussion in states that have robust elections.
However many of those we will still have, I know. One other question I have is there's a category of person called the big tech billionaire, and there's a few of them out there, and they're running companies. I'm thinking about like Mark Zuckerberg, for instance, and these guys have been talking about AI, and they're kind of putting their hands on AI and thinking about things to do with them. I'm not convinced that they really know very much about it. And I just wonder, what's the risk of having big tech billionaires decide to deploy AI in ways that are, I guess the nice way to put it is counterproductive?
Well, I think it's the same as the generalized risk of having someone who can make change, make a decision about something they don't know about. Right. So I don't think it's unique to billionaires. I don't think it's unique to AI. That's getting a lot of press right now. But I think, if you think about government making legislation about things they don't understand, you could probably come up with some examples of that. I think it's a similar category.
My major concern is that a lot of these people, I think, are deliberately hyping up either the existential risk of AI or how great it's going to be in order to sweep under the rug all of these smaller scale harms that are happening right now that really should be addressed right now, like recommendation systems from Facebook, for example, are causing a lot of harms, right? But if they sort of say, look, a squirrel over there, then maybe you won't be so inclined to, sort of poke at what they're actually doing. So I feel like they are spending a lot of time and energy trying to distract you from things that are happening right on the ground right now.
I believe that for sure. Well, we have reached the end of the hour. Can you believe it? This has been a great conversation. We really appreciate the time that you've taken with us today. And maybe you'll come back sometime. Because I think there's lots more to talk about. Well, thanks so much.
You can stay in touch with Plutopia at plutopia.io. On Facebook, look for @Plutopia News. On Twitter, it's @Plutopia. This is the Plutopia News Network, 20 minutes into the future.